So we have a thin rod, 2 meters long, with a charge of negative 2 times 10 to the minus 7 coulombs, lies on the x-axis centered at the origin. What's the direction? What's the electric field? What is the electric field as a vector due to the rod at location 0.03, 0.050 meters? Okay. So talk to your neighbor, draw a picture, think about approximations. Are we able to get away with using the approximations that we talked about in this case or not? And think about the direction of the field. Okay, so we have a number of different answers. We have 3 is popular, 0, negative 3.6 times 10 to the 4th, 0 newtons per coulomb. 2 is popular, and 5 is popular. Well, okay, let's take a look at this. First of all, we have a rod that's 2 meters long, and the observation location is 0.03, 0.050 meters. So that's 3 centimeters, comma, 5 centimeters, comma, 0, compared to, this is 1 meter, and this is 1 meter. So 3 centimeters over and maybe 5 centimeters up, I don't know, is maybe right there. Okay? Can we make the approximation in this case to just treat it like a thin rod where we're very close to the, our observation location is very close to the charge, and we're not too far off the axis, right? So this seems like a good place to make this approximation, right? So already we know that the electric field is approximately pointing in what direction? It's a negative charge. Should be pointing down, right? Should be there's going to be a slight lateral component, right? But essentially, since I'm so close here, my vector is going to go through the rod, but that's okay. I'm drawing a different color. The electric field is pointing downward. Okay, so we should get a net electric field like that. So let's try it. We have the electric field of the rod. Remember, this is just a magnitude, so the vector, you often have to sort of construct the vector yourself based on the sign of the charge. So we'll just get the magnitude. The magnitude is going to be 1 over 4 pi epsilon 0 Q, 2Q over L, and it's really the magnitude of Q, over R. So we have 9 times 10 to the 9 times 10 to the 9th times 2 times a charge of 2 times 10 to the minus 7. And yeah, I know it's negative, but we're just looking for the magnitude. Divided by L. Okay, so the length is 2 meters. And what's R? Right, so that is what number? Is it 0.03 or 0.05? 0.05. Okay? So what do you get when you plug that in? I didn't even actually work it out. It's going to be, well, the 2's are going to cancel. You get 18 times 10 to the 2nd divided by 0.05. So what is that? Okay, so it's 3.6 times 10 to the 4th. It's just a magnitude. It's just a magnitude. Okay, so I'm writing Q here, but the way to think about this, it's really the absolute value of Q because we just found the magnitude of these electric fields. Okay, so magnitude is always a positive number. When you want a vector, though, you have to look at the physical situation. You say, okay, this is a negative charge. I'm above the negative charge. It's got to be pointing towards it. So when I would write the vector, the electric field of the rod would be 0, negative 3.6 times 10 to the 4th, 0 in units of newtons per coulomb.